Hello everyone. Today I'll be talking about a maintenance Odyssey. While submitting the CFP, I was like, what should I submit? And then Nabarun was like, you should share some war stories. And I was like, okay, should have a couple of war stories, and then I submitted it. But then during writing the slides, I was like, we don't have a lot of war stories, but we do have experiences. Because over the time, we have invested a lot on technologies, we have transformed a lot. So this is a talk about those learnings and talking through how we implemented the changes that we brought into the project that I work for. So I have an agenda. The agenda is primarily to talk about the experiences, so I don't have much written here. I usually have all the slides that I would be going through, but this time it's a bit different, so I'll be going through a timeline on how Flatcar, the project I worked for, evolved over the years. But before starting, so let me introduce myself. I am Sayan Chowdhury. I have been working on Flatcar for the past 5 years now almost. I am part of the Microsoft AZ Core Linux team. The team is under Azure, but my primary work from day-to-day work is primarily on Flatcar. Before this, I have been part of other organizations, but I usually have been involved with various open source operating systems, and it has turned out to be an area which I really love to work on. So let's talk a bit about the history. So Flatcar, usually when we start a Flatcar talk, we set some history because it has a bit to talk about. You probably have heard of Gentoo. It's an operating system where users who love to play with their systems a lot. You get to compile all the images in your systems and can optimize to your needs. I'm a Fedora user, but when I got into Flatcar working on Gentoo, I was amazed by how powerful the whole ecosystem of Gentoo is. And then there comes the CoreOS. So CoreOS was based on Gentoo. It was built to use the features of the update mechanism that CoreOS has, and that's what Container Linux used. So CoreOS back in the day used these two technologies, Gentoo and CoreOS, to build Container Linux, and that's where the story starts to emerge. And in the year, I guess 2017 or 2018, CoreOS was acquired by Red Hat, and the project was turned into Fedora CoreOS, but a direct fork was built out of it, which was called Flatcar Container Linux. So the Kinfolk folks, the company behind Flatcar, they used to work with the CoreOS folks on a bunch of projects. And then while working with them, they really they really echoed with the values that CoreOS had back in the day, and they tried to bring that forward with the Flatcar Container Linux. So on March 6, 2018, they announced the Flatcar Container Linux projects. This was soon after the Red Hat acquisition, I guess. It actually lists all the ideas that they had in much detail, but in between the time frame of 2018 to 2020, nothing much happened. So the project was primarily ingesting, the Flatcar project was primarily ingesting all the changes that Container Linux was doing, because after the acquisition also, the Container Linux project was active for a long time. And the Flatcar people ingested all the changes in and kept on releasing the projects as it went forward. So if you see our release logs from 2018, you would notice that the upstream it used to mention this upstream Container Linux updates. So what you used to do is that you used to pull those changes in and run those through the CI and try to get that out. But I think they did the first announcement on March, but it took them almost 2 months to set up the whole infrastructure, because Container Linux as a project is built on a bunch of different projects. So if you visit their repository, the GitHub org as well, you will see a bunch of projects which would have the packages, it would have the update engines and everything. So it took almost 2 months to do the first release. And once it was done, for the first 2 years, they would just pull the updates from Container Linux and do those updates. And then comes 2020. So in May of 2020, Container Linux, the CoreOS folks announced that the Container Linux was go EOL, which is basically the end of life. And then that's when, almost towards the end of 2019, they started planning things. And 2020 was the year when they, from the beginning of 2020, they started to invest time working on Flatcar to make it better. So the first thing, this was also the time when I joined it. I joined Flatcar in April of 2020. So this was a bit before my time. So this, if you see the date on the top, it's written 21st January 2020. So this is a document that they created to see how the Flatcar releases looks like. So if you see, everything is red right here. So, and if you see the Azure here, that says the tests do not run, AWS has tests do not run, is basically red. The same goes for DigitalOcean, Google Cloud, and Packet. So primarily, everything was in a scenario where we need to work on. So CI and test grids are something which we really heavily we heavily imply on, and we work on those to we rely on those to get on our test to get results. Now, a month later, we start to see a couple of greens here, a couple of yellows, but this is towards the direction of getting things to green, and seeing that at least on a couple of cloud providers, we are able to provide a couple of good test cases. We started adding a few test cases, tinkering with it, and seeing that test runs on those few of the providers that, like the major providers. Then comes the last report, which was around March, I guess, this one, where you see a bunch of greens, and that covers mostly the AWS, Azure, DigitalOcean, Packet, QEMU as well. The QEMUs are local, so, but yeah, we are seeing a lot of greens in here. Now this sets the tone for the future ones. Like we started using this as a benchmark, but if you see, a lot of things has been doing in Excel. So a lot of thing in those days was heavily manual. Everything was done in manual, and I'll be covering those in the later slides. But if you have seen, like now Akhil was talking about like packaging containerd. So in most of the distros, package maintenance is one of the heavy jobs for any maintainers. For example, the Red Hat has this whole, the Red Hat Fedora ecosystem has this huge list of package maintainers who do their package maintenance. You have Debian package maintainers. In Gentoo also you have package maintainers. For us, it boils down to, so one of the easy parts is that we ingest Gentoo as our primary OS, and use ebuilds to modify them. But at the end of the day, as Priyanka mentioned, maintaining patches is a very difficult job, because whenever you are trying to pull in a new version, you will see breakages happening, you will see conflicts happening. So that's a very tough thing to maintain. And as package maintenance starts to happen, if you remember the last one that I showed, so in Container Linux, when we were ingesting Container Linux, we used to have this upstream Container Linux, but slowly we started to have our own package updates in. So we started, like for example, this is one of the early ones, the first release that happened in 2020 after the CI thing got green, which was on April 15, 2020. And we have a couple of packages updates going in. And another thing I would like to mention here is that the releases that happened in Flatcar was at a 2-week cadence compared to the traditional OSs where a new OS gets released every 6 to 8 months, but we were doing at a higher pace, which is of 2 weeks. Now, so yeah, so we started doing manual updates of our packages, and here you can see that we have a couple of packages. So we were creating all this manual PRs to create whenever, like manually updating all the packages. Then because Core Container Linux was going end of life, so they actually stopped maintaining a lot of packages. And what happened was a lot of packages got outdated over time, and it was almost outdated for 2 years, and we had to manually first, in the first year of 2020, we actually manually went through a lot of process, all the packages to see, to update it to the latest version, and everything was manual. One of the biggest change here was the systemd, because we were probably backed by 2 versions. If you see here, the systemd, I created the PR on May 15, which was to bump up the systemd from 241 to 243. And you will notice that if you see the systemd release note, they actually covered a lot of changes in a single release, and a few of them could be breaking changes as well. But we had to go through this pain to manually go through every package to update them. And one thing I would like to mention here is, if you see on the left side, there's CoreOS overlay and portage. So primarily what portage means is that any packages that are which has no changes and directly is fetched from Gen2, we put it into portage table. And if they have any changes in the e-builds or carry patches or any changes, or our personal packages, they go into CoreOS overlays. So this is a very recent stat. So we started, so to know what is the health of the packages, we built a small tool which would give what are the outdated packages. And this was pretty, at that time we did not have, I did not find the script that I wrote, so it basically used to spit out an Excel file. But this is a very newer thing that we built, but this is probably from 2-3 years back. But if you notice here, we had total of 548 packages, portage as 398, CoreOS overlay at 150. And one thing to mention was the outdated packages even 2 years back was around 232. So these are the things which we kept looking at. And the issues that we faced was like, we had to create individual PRs. Every PR had to be CI tested, so we were wasting a lot of resources on that. Tracking overload, so to track each and every, track 548 packages out there to see which one is getting a version bump. Suppose we have updated one, and by the time we update other packages, this on the previous one also gets a bump. So this was getting a bit of a tracking overload, and finally there's an efficiency drop, because the idea of Flatcar was to keep the packages as new as possible. So these are the issues that we faced, but we were slowly going through them, and we were hitting, every month or two, we would see that the number of outdated packages were getting lower and lower. And that's how 2020 went, and 2021 was bringing up a bit of a speed into our system, and looking into the problems that comes next was the releases. So as I mentioned, we do a 2 weeks release cycle, and one of the issues that we faced was our release cycle was, if we started a release, it took almost 48 hours to complete a release, and so it means that every 14 days we were spending 2 days just to do a release. And that was time consuming because there were other work items that we had to work on. And this is where we brought in a person. His name is Matthew. He started looking into testing, and I personally started looking into the releases. But I'll go into the testing first. So when we were doing the testing, we did not have automatic CI triggers. So we were doing, anytime something failed, we used to look into it, do a manual retry, and the test failures were also a bit high. So as Matthew came in, if you see here, he started fixing a lot of the tests, started adding new test cases, removing all the older ones. So basically try to bring up a testing system which is more resilient to failures. And his main area was to increase the test coverage, is add more integration tests in so that we can identify loopholes. So whenever we find, so one thing in Flatcar we have is, if we see that something is breaking, we try to add a test case for it, because that might help in, so that we can see that our stables get more stables. And then finally optimize our test space so that we can reduce the time, the 48-hour release time, we can reduce that. So these are the few things we started to look into. And once that's done, the next few items was, We had a private release tracking, so nothing, at back then, it was not community, so the community could not see what's going into the release. It was a private release tracking. We had a manual changelog generation, and this was one of the painful thing I had to do. I mean, it took me almost 5 to 6 hours to write the changelog. And I used to cry probably every 2 weeks to seeing that I have, it used to give me shivers thinking that I had to write a changelog. And then manual CV tracking. So one of the major things that we get is a lot of companies heavily rely on the security scanners to track the CVs. So we had to list down, and we were manually tracking CVs. As you see, and finally the marketplace publishing. So this is another pain point. Once the release is done, we had to go manually through AWS, Azure, and Google Cloud to manually publish the images on their marketplaces. But, and we tackled all of them one by one. So the idea was here to keep it simple and stupid. This is some learning I got from my previous, so because I was leading the effort to make the release better. So one of the things that I had learned previously was if you keep tools simple, it's very easier for other people to quickly adapt when you're not there and pick up those things quickly in your absence. So this is like a state right now. I did a couple of iterations, but what I did was every release we create a simple GitHub issues, and where you see like there's a preparation stage, there is a build stage, there's a release stage, there's like a cloud and market cluster API, and then the announcement. So one person from the release picks up this task and does that particular section. Suppose if I pick up preparation, if I do, or usually for give an example, like Matthew is based on France. So what I can do is that Matthew starts the release late at night at my Indian time, and then morning I will have the builds ready for me to check everything. So probably build, I'll assign myself, and then I'll start drafting the go, no-go meeting docs for people to see. By the time Europe wakes up, they would have everything ready, and then the rest steps are easier. So we kept it very simple so that people can understand. People use this tracking doc to list their problems, their changes. If they face issue in a release, they come back to this issue and write down their problems. The next thing was the changelog. So what we did was, rather than going for a complicated setup, we started, because Flatcar uses this thing called tags. So for every release that we do, we basically create a new tag. So we create a changelog document which has bug fixes, changes, security, and updates. And for any change someone does, they create a markdown file. And once we are doing the release, the Jenkins directly spits out a diff of what went in, and we have the changelog ready. So this was very reliable. It took a couple of iterations, but this concept is so simple that like in 1-2 passes we got it right. And then we dropped down to 36 hours. The thing that was missing was we were still doing manual marketplace updates. We were still doing the manual CV tracking, which we automated at a later time. But at that point of time, we were at a stable state where we can grow more. We were having faster test cases. We were having a faster 36 hours. By the end of 2022, we started having a bit of 30 to 36 hours, but it was good. So 2022, we started focusing on optimizing the overall architecture that we had. So one of the first iterations that we did was updating the whole baseline infrastructure on what Flatcar builds on. So earlier we used to use this thing called, so there's this tool called Core that we used to use, which uses chroot, but then we dumped the whole thing and moved to building SDK containers. If you see here in the, I think it's not visible, but what it reads is that this is the start of the work aiming to create a SDK container and to make it a default SDK. So the idea was at every stage, so the stages looks like we build an SDK to build our releases on, and then we build the packages, we build the images, we build all the cloud provider images. At every step, we spit out a Docker image. We create a container image which can be reused later. And this also helps us with debugging. We can just pull the container and test in our local. This was not very helpful when you used to do the cork method. So this was a very huge change. It almost took like 6 to 7 months to get things right. And I guess just before 2023, 2023 beginning, we got the first iteration out, and it took a couple of more iterations to get it right, but this brought in a big change in. And this also, at the same time, systemd also introduced this thing called systemd system extensions. And what this primarily is that you can basically layer things on. I guess I have a slide, yes. So Flatcar essentially is a immutable OS, so you cannot write anything to the USR partition, but there was a project called TOS, which was not really liked in the community, and at the same time, given SysX came in, we really loved the idea and started tinkering around with SysX into our Flatcar pipeline. And what it does is that you have a SysX image which you can layer on top, and the final image would look something like this. It's basically the merge of the two file systems, and then you can use those binaries as a regular binary. And this is an implementation which we improvised on, and we sent patches in. So we send a couple of changes to the upstream, because what we believe is that in Flatcar that if we are doing something, we always try to port it back to the community. Even if we see if there's an issue, we try not to carry the patches, but try to talk with the upstream, try to refactor it to upstream needs, and try to work with them to bring those changes up to the upstream. And with those, I think that created a good base. And by the end of 2022, we were down to 24 hours. And this essentially was, by the end, what I saw in 2020 Flatcar and in the end of 2023 2022 Flatcar, it was a massive difference, because the whole architecture changed. We were essentially a lot different from what CoreOS Container Linux had in terms of architecture, but the philosophy was almost the same. Now, 2023 we used as a way to bring in more changes in. And this is where the package maintenance returns, and we heavily invested on automating those things. And so we started with a minimal draft, where we started looking into we wrote a system where it would check the diffs and try to merge them and create a diff. But one thing still remains, but it has been solved, was like, so if you notice here, it gives like what are the version it's bumping on, what is the. These all things we started to track in that particular tracker, and there are other changes as well, what happened in that particular PR. So this PR, if you see here, the number, this is like every week a PR was getting created, and if you see the number here, it's 171. So in this particular PR, a total of 171 packages were updated. So on a weekly basis, we were saying around 200 or 250 packages getting updated on our projects. And this gave a boost to our releases as well. So this is from one of the releases, and from one of our alpha releases, and we updated this number of packages. And this gives our users a sense of security, because the latest the packages are, the lesser number of CVs it would have, the better control the user would have. And at the end of the day, people will not have to like go over to find ways to use the particular package. Like for example, if we have an older package and we have an older package in our system, so usually people have to find ways to use the newer package in the system, and there would be issue tracker on how to use the newer packages, and then we have to give a workaround. So these all problems gets eliminated. And I think this is one of the best things that has happened in the recent past. And coming back to system extensions, so as I mentioned, like there's this sysx thing. So we heavily worked on 2023 to collaborate with Cluster API with different providers to work on a solution where we can make upgrading the Cluster API images easier, the upgrades easier, and that's when we started heavily investing. We almost spent the beginning 6 months, and we are still trying to bring in more providers. We are still working on getting this sysx to more providers. We have probably completed 4 to 5 providers. So this is something I'll be talking on tomorrow in detail on how we actually leveraged system extensions for Cluster API. So it tries to eliminate the image builder steps. The reason is when you use image builder in Cluster API, you end up managing a lot of those images. For example, we have, suppose, Flatcar versions for stable, and then you have three Kubernetes versions which are maintained. So for every release, we had to create three Cluster API images on just one provider and scale it down to multiple providers, and you can guess the number of images we are maintaining now. So to tackle this problem, we started looking into system extensions and replacing image builder with system extensions in Cluster API. And we definitely got a very good feedback. Every time we created a PR, we did a demo on the Cluster API SIG meetings. You can probably check it out. We had done in Azure, OpenStack, and others. But at this point, we are just focusing on trying to make things better. The changes that we are working on 2024 is still in progress. For example, we have been working on adding more providers. We are reaching out to more cloud providers to add Flatcar into the system so that it's more easier for people to boot their own systems. The next thing, I have been personally working on adding secure boot to Flatcar so that it makes our way so that people can measure boots and etc. into their systems. And we believe from here that we would have there are a few more ideas in the pipeline. So I am really hoping that once we have probably 2025 beginning, we will start wrapping those things up, and we will see those changes getting into the stable versions. And with that, I think I would like to say that this is the team that we have. This is the Flatcar maintenance team, but we are also thankful to the awesome contributors. For example, the sysx thing that I talked about, this year we have a lot of the sysx getting contributed by the contributors itself. We created the bunch of the core ones. Like for example, I did not answer Zakil's question, but we maintain the container D through a sysx. So that's something we are investing right now. So we are trying to make a good base, a good package. So we are trying to make a gallery of system extensions so for people to engage and work on. And the good part about system extension is they can be ported to other OSs as well. But it's a small team. We try to do as we take on challenges, but one thing we have learned over the years is that try to keep things simple, try to engage more upstream, try to help community upstreams, try to bring those changes upstream so that the whole of community can get the benefit from it. For example, be it this effort, be it the cluster API effort, or be it the system extension effort, we always try to give the patches in back to the upstream. And with this, I think it ends. So we have the website. We have the releases on our flatcar.org/releases. The GitHub project, which is Flatcar/Flatcar, is basically the issue tracker. So if you have any issues, I would definitely suggest you to try Flatcar. I have a tutorial on the 12th on which I will be showing a demo on how you can try your Flatcar, and there is a 4-part tutorial on the documentation as well. We host our community meetings. So Flatcar recently got into CNCF. It's one of the first distros to get into. So we have started we have been hosting the office hours, but we would definitely encourage more folks to join the office hours. We have on one of the office hours, which is the second week, uh, the first meeting basically happens as a meeting where people show or demo what things, new things they have been working on, and the second one is more developer oriented on what would be happening or what goes into Flatcar. And the last two links are our Slack and Matrix. We are active on Slack as well, so most of the user queries I have seen on coming on this one. On Matrix, we have all our developer discussions happening. And with that, I would like to open it for questions if you folks have any. Yeah.
Thank you, Sayan. One question I have, you mentioned Flatcar is an immutable Linux operating system. How does the immutable upgrades work? Is it, so I am aware of transactional updates on one of OpenSUSE flavor of immutable operating system, be microOS. So I would like to understand how immutable upgrades work.
Yes, so what we use is a USR A-B partitioning. As you mentioned, there are different types of ways people do it. So what we do is that after every release, we create a package like a payload, and we update it to our what do you call that? Like the update manager. And what it does is it tries to install. So suppose if a main OS is installed in USR A, it will install this. It will try to install it in USR B, and if if it's a success, then it switches it to USR B, and if it fails, it notifies you and keeps USR A as a partitioning. So I recently did a workshop around the same. Like we have people releasing, using Flatcar for 4 or 5 years now, where they install the first release and everything has been going very smoothly. Unless if there's a breaking change, we let them know through our website, and we try to heavily, like right now we did like the Docker update was one which could be a breaking change. So that thing we let people know like for 4 or 5 months that this would be a breaking change. So in that scenario, they would have to look into their config and all those things, but other than that, usually the updates are pretty smooth. Like you wouldn't need to worry about it. It uses the same protocol that the Android uses, the Omaha one. So it's usually like once the update is, it will install and you won't even know that. If until unless you stop it manually, it will always be there on the latest one.
Okay. How many, like you mentioned about the change log being a pain. Does the change log actually includes every package level change log?
No, it does not include the package level changelog, but for every, so if you notice the package updates, so how we notice, so the bug fixes would include the bug fixes, the changes would include changes which has happened and is user facing. The next one is security, there is security. It mentions all the packages which has CVs in it and are updated in this particular. And the third thing is updates, where we list all the packages. I'll show you. So if you see the packages, these are hyperlinks. So these are actually linked to the change logs of that particular package.
Okay.
So this is something, so people can go to that link and see the change log. So this is also something we track, because some do judge, there have maybe a mailing list, because some would be on their GitHub tracker, some other, like Linux has like the LWN thing which we track. So these are all things which we have started looking into, but you will always have a link to the changelog in the packages. Yeah.
Okay. One last question. Flatcar is a Kubernetes special purpose operating system. Is that correct? Or
Not really. It's a general for it's a container optimized. You can run your Kubernetes workloads as well, but it's container optimized.
Okay. So from what I understood, how you explain it kind of feels like a rolling release phenomena.
Yes.
Okay, you answered. So it's a rolling release.
Yeah.
Thing. Okay, thank you.
Hello. the locus of control, now that Microsoft donated the project to the CNCF, as in it's in the process. So how does it, like you as the core contributors, is there any change? Do you all have any greater degree of freedom? How does it affect contributors as well as the core people?
So one thing is with this, I think it would definitely. Okay. So to revert back, so as I mentioned about the private tracking, right? So one thing we have always tried to do to keep everything in public, try to do everything, every development, every discussion to do it in public, and this helps us more. There's not much changes happening on the development side. We actually, what we believe is we'll get access to more people using Flatcar. People will get to know more about Flatcar. We might get more contributors for Flatcar, and but at the end of the day, we think if we move to CNCF resources, we would start using those as a way to, so that we can have more external contributors. Right now, like if you see, these two person, these are actually external maintainers. All of them are employed by Microsoft, but other than that, these two are. But we want to increase this base to more people from outside maintaining Flatcar. So that's one of the target areas for us. Yeah.
Kind of the point of the question.
Yeah. Yeah.
Sayan, can I ask one more? You had a slide where you mentioned root FS and then system extension.
Yeah.
What kind of file system Flatcar uses?
What kind of fly system is it?
As in, is it like a Btrfs or?
Yeah.
Okay. Thank you. Thank you.
So this one, the SysX actually has a multiple type of, it can be overlay FS on others as well. But yeah, so that's the limitation for SysX, so yeah. And one thing I wanted to go for. So to answer Jason's question, so one thing we actually wanted to go more into, so right now so during the release, a lot of the things are actually done by the people who have the access. And with this CNCF getting Flatcar getting into CNCF, this is also a place we would like to work on where external people can actually try to do the releases and maybe like take with small targets, but overall like over time they can do the whole release process. So this is one area which we would like in the future for external contributors. Yeah.
Hello.
Yeah.
Hey, Sayan, I have a question.
Yeah.
So you talked about upstream, right? The
Yeah.
upstream from Flatcar.
Yeah.
So what is upstream for you, like? Because I remember like the CoreOS is the upstream for Flatcar for a few years, where you used to get ignition and everything to Flatcar. So is
Yes.
it still there, or you started maintaining your own stuff now?
So upstream as in like, so when Flatcar and Container Linux was there together, so we used to like our remote for the projects was Container Linux.
Yeah.
And we created the fork, but it were independent forks, and we just had the remote pointed to Container Linux, and we used to pull those changes whenever there was a release. We used to pull those changes in, be it for ignition, be it for something else. We used to pull those changes in. And right now, what the situation is, because all the upstream right now for us is like most of the packages are like we are the maintainers of those packages, but when I mention upstream is like, for example, ignition. Ignition is primarily maintained by the CoreOS, Fedora CoreOS folks, but all our changes, we try to push it to the ignition. We were maintaining ignition separately, but then we tied up with the Fedora CoreOS folks to work with them on ignition. Yeah. Any features we need, we directly push it to into that repo. There are other repos as well, but there are few repos which Fedora CoreOS folks still maintain. So yeah.
Yeah, there are a couple of repos which are died down basically.
Yes. So
ignition is one of them. Actually.
Ignition is still there. If you go to
there is no there's no development, active development. If you see that, it's just like the maintenance part where they are.
No, ignition is very heavily developed because Fedora CoreOS also uses ignition for bootstrapping.
Yeah, what I remember, like for last couple of months, there is no development at all. But yeah, I don't know, like.
Okay, we can talk about this later offline, but I'll show you on where the development is happening. But recently, if it so when Container Linux was doing, They stopped at V2, and then Fedora CoreOS did V3. We
That was the
actually,
last.
yeah. So we actually did a backport support for V2 as well. So we supported both. And another thing when I mention upstream is like because we pull in Gen2 packages in, a lot of time there might be issues with Gen2 packages. We push the changes back to Gen2. Actually, one of the person in the team, he's actually a Gen2 code. His name is James. We call him Chewy. So he's actually on the Gen2 core. So his work is like to look into like pushing those changes in, but we try to tend to push those changes back to Gen 2. Yeah.
Thank you.
Okay, I think that's all, and thank you everyone for joining.